Hey everyone, welcome to another edition of Sippin Ground Coffee, our live stream broadcast. My name's Dan Painter, and along with Renee and Derek, we're going to make this all happen this morning. Before we do get started, make sure you hit that like and subscribe buttons there as you're viewing these tapes. Also, hit that bell. That'll give you a notification every time we do a live broadcast like this. You'll get a notification that this is getting ready to take place. So also follow us on Facebook, follow us on LinkedIn, and go to our website. If you haven't been there, go to flintandwalling.com and sign up for our newsletter. That gets emailed out, I don't know, pretty much probably 3-4 times a year, but it's a way of letting you know what's going on up here. And then the last thing before we do get started with today's presentation is there's going to be a code word, and I will give it to you later in this presentation, but write that code word down, because when you email 3 of those code words in, and each of these have their own code word, when you email those into marketing@flintandwalling.com, 3 of them, you're going to receive a tour and training shirt, and these things are pretty bomb. They're nice. Everybody that's seen them likes them, along with some other swag. But make sure you jot that down. So with that all said, got that out of the way. Today's topic is the Commander Pro variable frequency drives. And when we talk about the Commander Pro now, we're going to be talking about the TVS series. A month ago, we did a presentation on the Commanders 1 and 2 frequency drives. This one today is different from the previous 2 drives. This Commander Pro drive actually was introduced back at the time we launched our motors. So this is going back probably 10 years or so. And like all electronics, right? Over that 10 years, there's been advancements. There's been some evolution take place. But these drives here that we're going to talk about today are available in 1.5 horse, 2, and 3 horsepower by their model numbers, the TVS 15, 20, and 30. They're going to be operating either 3-wire single phase or 3-wire 3-phase motors. All right. So again, these are the 3 models that we're going to talk about. Now today, we're going to spend this time talking about how to set this drive up once it's been installed and it's hanging on a wall. So we want to talk about how to set it up. And of course, all these drives are going to ship with an instruction manual. And I've looked at these manuals, I've looked at competitors' manuals, and they get to be, quite thick, especially with variable frequency drives, to the extent that a lot of people probably, for that reason, just they don't pay much attention to them. However, we're going to put a quick start guide in there. Pay attention to this, because this is the one thing that'll keep you from leaving the job site with your fingers crossed, all right? So this quick start guide has everything we need to be able to set that drive up initially, again, so that we can leave with confidence that it's going to be functioning fine for us, right? Now I'm going to go through this quick start guide. At the top, you can see that we have six buttons. Starting from left and moving to right, you have your up and down, followed by the edit, the enter, escape, and then the last button is start and stop, all right? The edit button allows you to make a change to any of the parameters of this drive. If we're going to make any changes at all, we're going to hit the edit button first to make that change. Your up and down buttons then will allow you to scroll through your options of what changes you want to make on that drive. And once you've made that selection, then you hit the enter button, and that saves the change. So again, edit allows you to make a change, up and down allows you to choose the change, and enter allows you to save that change. The escape button is going to take you right back to the home screen no matter where you're at. It's going to discard any changes you made. It's just going to take you on back to the home screen. If you happen to get distracted or a phone call and you're halfway through this, hit that escape button, and no harm, no foul, you can start all over again. Stop start button, if that one needs an explanation, help us, okay? So let's move down now to these buttons here. The edit and enter button. This is what you're going to need to do to get into the drive programming. You're going to need to use 2 fingers, press that edit, enter button simultaneously, hold it down, I don't know, count to 3, and release it, and then bingo, you're into the programming mode. Now the reason that that's designed that way is just to, you know, keep inquiry minds out. You imagine a drive hanging on a wall, and a couple of young boys walking by it, and they see this thing's got lights on it, and it's also got buttons on it, and hey, I wonder if what'll happen if I start punching the buttons. Well, nothing's going to happen, because the only way, again, you can get into that drive is you're going to have to hold the edit and enter button down simultaneously. The other two buttons that you can hold down simultaneously once you're in the drive is the up and down buttons. And what that up and down button is going to do is it's going to take you into a fault log. This particular drive, these TVS series drives, will store up to 20 faults. So you've got a history there of faults with a timestamp. And so it's a revolving fault code or fault log that we keep. So example, if by chance you filled up all 20 of those faults, all right, so the log's full, and now all of a sudden another fault takes place. Well, what's going to happen is that fault that just took place is now going to take position number 1, and it's going to bump everybody down 1 notch, and so that means that what was in the number 20 position gets knocked off, all right, so it goes away. But that's how that works, and that's what we're, excuse me, we're talking about when we say a revolving fault log. Also in that quick start guide is this information, all right? This is max motor amps. Very important to know this because that's how we're going to set the drive up. We're not going to choose a horsepower. We're going to set it up based on max motor amps, because there are different motors out there, and even though the horsepowers may be like horsepowers, the max motor amps could be different for those different motors. And so, as you can see in the quick start guide, we've got the 3-phase listed out, 1.5 through 3, or I'm sorry, through 5, and then the single phase 1/2 through 2. And you've got several manufacturers there, so there's where your max motor amps are going to be located, all right? So now, that all set. Let's go ahead and get ready to program this guide based on that quick start guide, all right? Based on that quick start guide. So now, what happens when you power this drive up for the very first time? This only happens on the initial power up. What we're going to do is we're going to take you right into that quick start guide. What do you mean? Well, when you hit enter, now it's going to ask you, what motor type are we going to operate? Is it a submersible? And again, you can use your up and down buttons, there you go, or is it an above ground like a centrifugal pump motor? So again, you've got submersible, above ground, you make your choice there, and then you would hit enter to make that selection. So let's just run on the premise that we're going to go ahead and select a submersible motor. So then if it's a submersible motor, it's going to ask us, is it a 3-phase motor or is it a single-phase motor? All right, so those, again, this is not difficult things. It's all part of this quick start setup initially. We're going to educate this drive on exactly what type of motor it's going to have to operate. So again, there's your choices between 3-phase or 3-wire single-phase. And then this next menu, what are we, number 4, I think, on our menus here, number 4. This is where we're going to set that max motor amp. And again, when we look at that 6.0, that would be for a 1/2 horsepower motor. That 1/2 horsepower submersible motor. You know, if I were running, again, this is a 1.5 drive, so I can run anything up to that 1.5. So if I were running a 3/4 or a horse or even a 1.5, there's where I would change and put in the max motor amps for that specific horsepower. So that's where you would make this change. And that's what we're doing, is we're telling the drive what horsepower it's going to operate. Menu, I think this is menu number 5. Let me just check this real quick. Menu, oh heck no, this is all in the quick start. Never mind, this is all part of the still quick start here. Maximum frequency, all right? So here's where we can set maximum frequency. This maximum frequency is showing 60 hertz. You would run 60 hertz if you were running a matched pump and motor. In other words, the pump end by horsepower is matched to the motor by horsepower. So you got a matched pump and motor horsepower. Flint and Walling not only does it this way, but we historically very successfully have run mismatched pump ends and motors. We'll take a 3/4 horse pump in and throw that on a 1.5 horse motor, and then we just spin it faster. We get a lot of efficiency out of it that way, but we'll run that thing all the way up to 80 hertz. All right. So again, if you're running a matched pump and motor by horsepower, then you're going to run that at 60 hertz. If it's mismatched, you'll run it up to 80 hertz. If it's an above ground, had we selected an above ground pump or for our motors, like a centrifugal, you're always going to run those at 60 hertz, never above that. So in fact, on a above ground motor, it wouldn't allow you to make any further changes to that hertz other than that 60 that's up there on the screen. And then this last thing we're going to set here is we're going to tell the drive, what are we using to turn the pump motor on and off? Is it a transducer, a pressure transducer, or is it a switch? Because this drive will operate off of either one, a transducer or a switch. If you select transducer, and I'm going to guess 95% of the time that's what's taking place, is we're selecting a transducer. That's what they're shipping out of here with. When you select that transducer, what's going to happen is you're going to have a sub-menu now come up. And there's going to be three things there. All right, here they are. The first thing is it's going to say, well, what's the pressure range of that transducer? You probably won't have to change this at all because this is going to be factory set at 100 psi. And that's what we send out with with these drives. Now there are larger transducers, higher psi transducers available. If it were a 150 or 300 pound transducer, here's where you would make that change. In that menu, you would move that from 100 psi up to whatever that range is on that transducer. It's also going to ask you to set your pressure set point here. And this is what a lot of contractors have liked over the years versus the pressure switch, is that they can actually set the pressure set point right here with their up and down scroll button. So you can run the pressure up if you want to go up higher than that 50 psi. And like I said, you can go down if you want to go lower. But that's where you're going to set that pressure set point. And then the last of that three menus, and this is simple stuff here. The last of that three menus is what's simply called drawdown, all right? How far below that pressure set point, how many pounds below that pressure set point do you want that system to drop before that drive comes on? It's going to leave here at a factory default of 5 psi. So if you've got a 50 psi set point, that drive is going to kick on when that drawdown gets down to 45 psi. Now that is also adjustable, as are all these menus. They're fully adjustable. You hit the edit button up and down and hit the enter. It's that keystroke that's consistent throughout the programming of this drive. This is what that transducer would look like on the bottom. The pressure switch we referred to is located up there at the top. Now with that pressure switch, to set the pressure set point, you take that rubber boot off the top of that switch, and then with a nut driver you can go down and, like a conventional pressure switch, you'll crank this thing clockwise to increase the pressure. You probably have to look at a pressure gauge to watch where you're going with that. But nonetheless, that's how you would set the pressure set point on a switch, which is why a lot of guys like the transducer, because it seems to be something a little easier to set. All right, so once you've done that, that's the startup menu, all right? That's the startup menu, and it doesn't take too long to run through that, as long as you know what motor you've got, what the max amps are, so on and so forth. But once you get through that startup menu, it's going to say press start to continue. All right, and when you press that start button, that far right button over there, it says start to continue. Here's the display now. It's in standby. We've got our pressure set point at 50 psi. No amps, no hertz. That drive's now in standby. That initial quick start now has gone away. We've programmed it in here. From now on, anytime I want to get into this drive, I'm going to have to hit the edit and enter button simultaneously. All right. When I hit that edit and enter button simultaneously, let me tell you something. There are 10 menus. Not 15, not 20. There are 10 menus in this drive. And so let's just look at some of these, and we'll go through them here real quick. Number one, control. That menu control. Are you running a switch or a transducer? All right. And if it is a transducer, you're going to set the range, you're going to set the drawdown and the pressure set point, like we talked about earlier. To be honest with you, if you don't even tell the drive what you're using, it'll figure it out. It'll come back and it'll tell you, hey, I found a transducer found. or pressure switch found. So it'll detect what we're using, should we not tell it initially, whether we're using a switch or transducer. That menu number two, that's where you're going to plug in your max motor current, all right? That's, again, going to be based on horsepower. And you can use that quick start guide if it happens to be somebody else's motor. You can use that quick start guide and look at whatever their max motor current would be and set it up accordingly. We talked about this a few minutes ago, the max frequency, that can operate anywhere from 50 to 80 hertz. 80 is going to be for mixed match pump and motors, and 60 hertz for all pump and motors that are matched. Menu number 4, that's passcode enabled. Kind of a neat little feature here. That's you can plug in a 5-digit passcode number so that now once you hit the edit and enter button, now what it's going to do is prompt you for a passcode to go any further, right? So that's a way of protecting the drive so that you don't have any inquiring minds that want to get in there and possibly change something. When I've mentioned this in classroom, inevitably I'll get somebody raise their hand and, hey, painter, I said, what happens if I have to go out on a drive that I didn't sell, and maybe the guy that did sell it, you know, he had it password protected, but he's not in business anymore. So now, is there a way that I can get into that drive? Y'all certainly have some kind of a back door, don't you? Well, of course we do. Of course we do. And it's very, very easy. It's the Flint and Walling zip code, all right? So look up the zip code for Flint and Walling, Kendallville, and you got the back door to get into that passcode. By the way, we've made it easy. There's a sticker on the side of the drive. It's got our address on it. So there you go. It's right there on the side of the drive. Menu number 5 is going to be for underload protection. Menu number 6 is standby sensitivity. And then number 7 is broken pipe. That's a simple timer that you can set to operate anywhere from, you know, half hour up to 48 hours. In other words, if that pump is, let's say it's been set for 3 or 4 hours, and that pump's been running constantly for 3 or 4 hours, hasn't built up pressure, hasn't shut off, that's going to kick off into a broken pipe mode. It's going to assume that you've got a broken pipe somewhere. You can also totally disable that function if you want to. Number 8 is advanced features. That's where, not in there very often, but if you have remote alarms or float switches and things like that we want to operate, there's certain ways that we can wire those all into the drive and make all that work. Number 9 simply restores you back to the factory default. So you hit number 9, it's going to go all the way back. And by the way, you hit number 9, guess what? You're going to go through that quick start guide again. Number 10 is control settings. Not often at all do we get in here. Very rarely, but those occasions where we do need to get in and adjust the ramp rates or calibrate the transducer, these are things that we're able to do that keeps that drive from having to come back to the factory, that can tweak it up and for that particular job, all right? So let's look at these last, I'm going to finish this presentation off. Again, this whole thing was more around how to program this drive and set it up when you first install it. But I want to talk about number 5 and number 6 because in my opinion, number 5 and number 6, an understanding of those two will keep that drive from coming back off the wall and going back to the factory. I mean, there's often times that we can stand there and just with knowing how to tweak the drive, we can get out from underneath a fault that's been going on and causing us frustration. And the last thing we want to do is put a replacement drive on and the same daggone problem's occurring, right? And that's happened more times than we like to talk about. So let's go back and just review this underload protection and this standby sensitivity, all right? Underload protection, right? Let's, when that VFD is operating, this is true with any VFD, and certainly all the different VFDs Flint and Walling has, this is going to be true. These are the measurables. This is the list of things that VFD has the ability to measure. So you see at the top it runs from voltage to the amps to the system pressure, frequency on down to the the temperature and cycle runtime. This is the only measurements. These are the only measurables. On there is not gallons per minute. These drives don't know if you're flowing water or not. All right, they have no idea. It's not up there. It's not something they measure. They only know what's being listed on the screen right there. So keep that in mind. A lot of people think that drive ought to know whether water is being used or not. Oh no, it knows what's being up there on that screen. All right. So what is underload? What do we talk about when we have underload protection, right? Well, underload's typically going to occur if you have a pump that's running dry, all right? Not something that we like to see happen, but if a water table is dropped down and you got a pump that's running dry, you're going to be in an underload condition. Same thing would happen if you have a pump that's pumping against a closed valve. That condition is called deadheading. Very, very destructive for a pump to be in that kind of a condition. But either one of those is going to trigger an underload by these two measurables. Let's look at what happens. Well, first of all, if you're in an underload condition, you're going to have reduced running amps, all right? That's what's going to happen is your amps are going to run, but your maximum frequency, you're still running at full bore. But the amps are coming down, all right? The amps are coming down. And so if you look at, dependent upon the horsepower of the drive, again, when we set that max motor amps up front, it's also going to default to a underload amp protection here. And so that you can see like on a horse and a half, that underload is going to be at 3.9 amps, right? So what happens here is that when the motor's running at full speed, so it's at maximum frequency, that's at that set point, running full speed, 60 hertz, all right? And, capital letters, and the underload amp threshold is below the underload fault, all right? So here's the example. You got a TVS 15, that's a horse and a half. The amp frequency is going to be, or max frequency, 60 hertz. The max motor current on that is a three-phase motor, 5.9 amps. So when that's been set up that way, the underload default is going to be 3.9 amps. That's going to default. So every time you change that max motor current by horsepower, it's going to also automatically change that default underload amp setting, all right? So underload is going to occur when that pump is running at full frequency, 60 hertz, all right, running at full 60 hertz, and below that 3.9 threshold. That's when an underload is going to occur. And when that happens, when it happens and that drive goes into a fault, this has got what we call intelligent reset, something like that, intelligent reset. That drive's going to go back and determine how long did that pump run prior to that fault taking place. And then, therefore, it's going to determine how long it's going to need to keep that pump off for this system to recover. And that drive will come back on, and it'll determine whether that condition, in this case it was either a deadhead or a dry run, whether that condition still exists or not. And based on that, it'll either continue to operate fine, or it'll go back in and shut off again. I think after about the third time that happens, it will go into a hard fault, and it's going to basically stay off. You can override all that, again, go into the program, into that menu, hit edit, and you can reset that timer or reset that, that time that it's off, and you have that ability with the up and down scroll buttons, okay? All right, what is standby sensitivity? Now there's three measurables on the standby sensitivity. Again, what we just talked about with the underload, that's if you're running below that threshold on amps, but the motor's running at full RPMs, right? So here, with standby sensitivity, there's three measurables, right? That's going to be pressure, the motor amps, and once again, the motor frequency. And all three data points are preset with the assumption that below the set point, operation indicates that no flow, so the drive goes into standby. So in other words, those three thresholds, right? PSI, motor amps, and motor frequency. When we end up operating below those three thresholds, that drive's going to go into standby, all right? Go into standby. Conversely, oh, there's your code word for the day, folks. Conversely, write that down. We're not going to charge you, correct you if you don't spell it correctly. All right, write conversely down somewhere, excuse me, add it to another couple of code words and send that into Flint & Walling at marketing.com. You'll get those prizes we talked about earlier. But anyway, conversely, if any one of these data points is higher than that preset, well then what happens is that VFD is going to continue to run, and it's going to correlate that as there's water being used. Again, if it's running higher than that set point. So here's another example. When we're going to go into standby sensitivity. All right, so here's an example. PSI. That's a half a pound, right? Half a pound. That's what that PSI drawdown was. So this data point is going to tell the drive that when the pressure is within a half a point of that set point, all right, so if the pressure is within a half a point of where we want it to be, that drive is going to begin its standby operation. Okay, it's going to say, okay, maybe it's time to go into standby, but it's going to have to also look at those other two measurables. So the motor amps. What that data point is going to tell the drive is that when the current is at or below that 3.3 amps and, key word, within a half PSI of that set point, the drive is going to continue down that path of standby. And then this last it's going to look at is the motor frequency. So here, if we're running at or below 50 hertz, we're running at or below 3.3 amps, and we're running at a half a pound within the pressure set point, then and only then will that drive go into standby. It says here a situation can arise where a VFD will continue to run even when no water is being used, and what typically the result with that would be is in a broken pipe trip. All right, so the drive continues to run under a low load. There are several factors that can cause the drive to run higher than the preset points. Higher, keyword higher than the preset. If the system wasn't sized properly to begin with, so that therefore the motor, you need more motor and pump to make the shutoff. If the system's changed, such as the water table's lowered, resulting in a lower pumping level. If the pump's damaged or not operating at full efficiency, that happens sometimes when you try to take a system, conventional system, and upgrade it, or the system has developed a leak. All right, so as we wind down this session here, and I wanted to, again, circle back on this underload and this sensitivity. Let's look at this here. System is installed and was sized for 50 PSI. But the end user at some point decided, I want a higher pressure, right? So they went on ahead and they went and adjusted that pressure up to 70 PSI, which added another 46 feet of total dynamic head. They did not, on the other hand, change that current down there. So what happens? You got the drive, you got it set at 50 hertz. The default parameters are going to be at 50 hertz. The set point's going to be within a half a pound of that pressure, that 70 PSI, and the current is going to have to be below that 3.3 amps. Well, here's what's happening. No water's being used, but look at what your drive's displaying. It's displaying that 50, it's displaying that 70, and it's displaying that 47, but that 3.5, is where the problem's at, right? That 3.5 amps is where that problem's at. Because it's running higher than the threshold. And so therefore, the drive thinks water's still being used somewhere. So that's a nuisance, that's perhaps a nuisance fault that we can address this here, because if you replace this drive with another like drive, this same problem could occur, right? The same problem could occur. So the way that we address it is very simple. We're going to go into that set point for that 3.3 amps there. We're running at 3.5. So we need to get that set point above that 3.5 so that we get a green check mark on all three of those measurables, and the thing goes into standby. So how do we do that? Well, we're going to raise that threshold on that amps. Again, you're going to go into edit. You're going to hit your up button. You're going to take it up to 3.7 amps. And now your 3.5 amps are running below that threshold, and the drive will go into standby. There are publications available. Get a hold of your Flint and Walling sales guy and have him give you a few of these. These are little pocket guides, actually. These one's a motor application guide. It's for our 4-inch submersible pump motors. The other ones are for our drives, both the Commander 2 and 3 and the TVS drive that we talked about today. The TVS drive that we talked about today has all the bells and whistles. This drive is fully loaded with features. This drive has unbelievable diagnostics to the extent, if you have a broken wire this drive is going to tell you not only that the wire's broken, it's going to tell you which one. Red leg open may be a display that shows up in that display screen. Black leg open. It's going to show you exactly why that thing triggered a fault, and then it's going to store that in a fault log, again with a timestamp and a date, so that we can go back and see what's happening and when it occurred. Anyway, this presentation today was about basically the setup. If you go through that quick start guide as we talked about, and you make those selections, which are fairly easy to do, once you've done that, by and large, you've got a system that's set up and is going to operate for you. With that said, I think that's, I don't think I have did I have another slide? Nope, I did not. All right, that was it. I thought I had a last animation on. There it is, right there it is. Okay, look, when in doubt, pick up the phone. We have a hotline here. It's our groundwater support hotline. You're on a job site. You got a question. You don't want to take that drive off the wall. If we can solve the problem over the phone, standing right there, you're the eyes and the ears, and we direct you on what to do. That's a win all the way around for everybody. So don't take that 800 number too lightly. Use that when needed. Listen, that's all we've got for today. Appreciate you being on board. Look forward to the next time. Sippin Ground Coffee, another topic coming soon. Thank you very much.